Good evening, this is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic Review of Vector Algebra from the subject Electromagnetic Fields. So before getting into the topic, let's discuss about what is the electric field, magnetic field and electromagnetic field. Electric field is created by stationary electric charges, whereas moving electric charges creates a magnetic field. Moving electric charges constitute the current. Current carrying conductor produces a magnetic field. The combination of both electric and magnetic field give rise to the electromagnetic field. So changing electric field produces magnetic field. Changing magnetic field produces electric field. So this allows them to propagate as a electromagnetic waves. I am going to discuss about what is a scalar, what is a vector and how to represent a vector and what are all the operations involved in the vector and finally the real-time applications of a vector. So before starting with the vector, clear definition of vector, let's discuss why vector algebra is used in the electromagnetic field. And we all know that vector is a physical quantity which has both magnitude and direction. So this electric and magnetic field in electromagnetic field has both magnitude and direction. So the vector algebra can be effectively used to describe this electric and magnetic field. So it represents electric and magnetic field more compactly and also it involves the calculations more simpler. So that's the reason why this vector algebra is used for analyzing the electromagnetic field. And next one is what is a scalar and what is a vector. Both scalar and vector are the physical quantity, where scalar is a physical quantity which has only magnitude. Examples for scalars are time, temperature, etc. Whereas vector is also a physical quantity which has both magnitude and direction. Examples are acceleration, velocity, displacement, etc. And how to represent a vector? So a vector is represented as a line segment. It has a starting point and it has a ending point. The starting point we call it as a tail and the ending point we call it as an head. Here we will be using an arrow to indicate the direction of a vector. So the length of the line segment is a magnitude and the direction where the arrow points out, we call it is nothing but it is a direction of a vector. So the direction of the vector is indicated by an arrow and the length of the line segment indicates the magnitude of the vector. So vector has both magnitude as well as a direction. And next one is the operations involved in the vector. We are going to discuss about addition, subtraction, dot product and cross product. So addition, while adding two vectors, we have to consider both the magnitude and direction of the individual vectors. So here C vector is represented as A vector plus B vector. So while adding this A and B, we have to consider both the direction and magnitude of A as well as B. And this addition obeys a commutative property. So A vector plus B vector is equal to B vector plus A vector. And next is a subtraction. So two vectors can be subtracted easily using the vector addition rules. And next is a curiosity challenge. Among the four, dot product, cross product, gradient and scalar triple product, this gradient is an odd man out because it deals with the scalar, other things are deals with the vector. And next one is a riddle. I am 0 when vectors are perpendicular, positive when acute and always scalar. When what operation am I is nothing but it is a dot product. Third one is also in riddle. I twist and turn revealing a circulation in fields like magnetic ones, which is nothing but it is a curl. Curl deals with the circulation of a vector. And next is a dot product. The dot product equation is given as A vector dot B vector is equal to modulus of A modulus of B cos theta. So it indicates how two vectors are aligned with each other. If suppose A vector dot B vector is equal to 0, then it indicates that both the vectors acts perpendicular to each other. And next is a cross product. Cross product equation is given as A vector cross B vector is equal to modulus of B modulus of A sin theta. So it is used to visualize the perpendicular vectors. And next one is the real-time applications of vector. It is used in power engineering to enhance the energy distribution, and it is used in modern wireless technology to enhance and enable the effective communication, and it is used in medical diagnosis to improve the imaging techniques. And we have discussed about what is the need for vector algebra in EMF, and we have discussed what is a vector, what is a scalar, and what are all the operations involved in vector. And finally we have discussed about the real-time applications of vector. And these are all my references. Finally, assessment. A vector quantity in electromagnetism is defined by both magnitude and direction, which does not belong to vector triple product identities, which is nothing but a plus b plus c is equal to vector sum, which does not belongs to the vector triple product. So that's all about the topic review of vector algebra. Thank you.